any questions during the presentation, please type them into the chat, and we'll do our best to field them as we go along. With that, I will make Dennis take presenter on the little reins.
Good morning. I am Dennis Falloon, and I am a District 7 Safety Academy Coordinator and a District 7 consultant. And I'd like to welcome you to the second webinar of the third series of the District 7 Safety Academy webinar topics for 2015. Today, we're going to have the topic use and misuse of crash modification factors that will be presented by Larry Hagan, Special Engineer and District 7 Consultant. I wanted to briefly go through a little introduction. Some of you have seen this before, but just wanted to highlight some things. Naturally, this is the District 7 Local Agency Traffic Safety Academy, and its main purpose is to provide information regarding safety-related issues to enhance your local safety programs. This set of series of webinars began on January 28th. They start around 10 o'clock. Usually we start at 10:05, but we block off time 10 to 12 o'clock. They usually go for an hour, but no more than 2 hours. And these topics will run through to the end of the year, calendar year, December 16th. And I wanted to make a note to let everybody know that the length of the presentation will depend on what topic is being presented and the complexity of it. Also, I've put two links on here. One is to where you can go register if you haven't registered for any of these, and you're just in a room listening. You can do that. And also, I've listed out the link for the web page that Anthony just had up on the screen. And like I said, today we have use and misuse of crash modification factors. And I also wanted to bring you to the attention if there were any if there was any information that was previously out there regarding these topics. A couple changes have been made, especially for the next one, March 18th and April 15th. We've modified the topics. There'll be the FDOT statewide bicycle and pedestrian policy update, and then we'll have FDOT District 7 bicycle and pedestrian projects and safety initiatives. For those that could get the AICPCM credit, you'll have to go to the website locally to see about these courses and how they've been approved and when they've been approved to get that credit. If you're a professional engineer, you can go to the website that we had up, the link and everything, and get the form, and you can load that up, and you can either email it or you can fax it to Larry Hagan, and you'll get one PDH hour. And here's the link again to get the form to get your professional engineer hours. And this is my contact information. And if there's no questions, I'm going to turn this over to Larry. Anthony, can you turn that over to him, or do I need?
I got it.
Okay.
All right. Yep.
Okay.
All right. Can everybody see my screen now? Hopefully you can see my screen. We're going to talk today about the use and misuse of crash modification factors, and my subtitle is Fun, Fun, Fun Till Your Daddy Takes the T-Bird Away. That may sound a little familiar, and I'll get back to that in just a second. First, my standard disclaimer. We're going to talk about crash modification factors a little bit, but Certainly you're not going to be an expert in crash modification factors at the end of 1 hour of it. It still requires a lot of study and time to really understand it, but hopefully this will give you the information to at least get started if you don't know anything about it, and hopefully will help you learn some things if you've already learned a lot about crash modification factors, but want to learn some more. Hopefully you'll get some new stuff here as well. Actually, the reason I say you've probably heard fun, fun, fun till your daddy takes the T-bird away. I did a webinar very similar to this in the very first series of the Traffic Safety Academy on application and science of crash reduction factors, and it's very, very closely related to crash modification factors that we're going to talk about today. And so actually you'll see a lot of the same slides, a lot of the same information, because a lot of it hasn't changed. There is some new stuff, but really it's a lot of the stuff from that previous presentation, because it's really the same kind of stuff. The crash modification factors and crash reduction factors are very closely related, but they are distinctly different, and it's important that you do understand the difference between a crash modification factor and a crash reduction factor. And so we'll spend a lot of time talking about that and where to get crash modification factors and crash reduction factors. So what is a CMF? CMF is one of the many TLAs that we use in traffic engineering, and here are some others. ADT, HCM, HSM, and MOE. And so, well, you might say, well, what's a TLA? Well, a TLA is a three-letter acronym, and that is something we do tend to talk a lot in acronyms, and it's important that we do understand the acronyms and that the people we're talking to also have the same understanding of that same acronym. So anyhow, TLA is a three-letter acronym. Again, a CMF is a crash modification factor, and we'll look at that in a little more detail. And like I said, it's one of the many three-letter acronyms that we use a lot in traffic engineering. ADT, of course, is the average daily traffic. Hopefully most everyone on the call recognizes that one. HCM, probably everyone on the call recognizes that as well, as the Highway Capacity Manual. And the HSM, especially if you're dealing with crash modification factors, if you're dealing with CMFs, you really need to know what the HSM is. That's the Highway Safety Manual. And so hopefully you're familiar somewhat with that. MOE is another one of those three-letter acronyms, and MOE is this guy. That's Mo. Here's me, I'm Larry, that's Curly in the middle, and that's Mo. Well, actually, in traffic engineering, MOE is measure of effectiveness, and so we often talk about measures of effectiveness in traffic engineering, and we're trying to measure how effective we are at reducing crashes, or whenever we make a change, how effective we are. It's a performance measure is what an MOE is, really is, you're measuring your performance, measuring your effectiveness. And like I said, CMF is a crash modification factor, and the CMF is an MOE. The CMF, is a measure of how effective you are at modifying the crash rate. And so if you're effectively modifying the crash rate, if you're putting in some countermeasures that are reducing the crash rate or maybe increasing the crash rate, hopefully not too much of that, but if you're changing the crash rate, you will have a crash modification factor that's measuring how effective you are at changing the crash rate. Likewise, CRF is the crash reduction factor, and a little later we will spend some time talking about the difference between those two. Likewise, CRF is an MOE. Crash reduction factor measures how effective you are at reducing crashes. And so the terminology is somewhat important here, so it's important that we understand, again, the difference between a crash reduction factor, crash modification factor, and how you use them, and make sure you're getting what you think you're getting when you ask for one. Make sure you're getting a CRF if you ask for a CRF, or if you're asking for a CMF, make sure you have a CMF, because if you think you have a crash reduction factor and what you have is actually a crash modification factor, and you use that number, you could come up with the wrong results, or you will come up with the wrong results. Okay, you should see the definition on the screen now. The CRF, crash reduction factor, is an estimate of the percentage reduction of crashes due to a particular countermeasure. You've put in some new countermeasure, some new treatment, new signing, or new striping, or new treatment of some sort, and crash reduction factor is estimate of percent reduction due to that countermeasure. Crash modification factor is very similar. It's a multiplicative factor used to compute the expected number of crashes after implementing a given countermeasure. So you put in this change, whatever it is, signing change or roadway change or whatever, and what percentage of the previous crash rate will you be having in the future condition is what the CMF is all about. And so if you had, let's say, 10 crashes per year before, and you have a CMF of 0.8, it means after you put in this countermeasure, you're going to have 80% of the previous crash experience, or 8 crashes per year. So that's what CMF and CRF are all about. It's interesting when you really look at them. I like to look at some of the things mathematically sometimes. The CRF, the range of values for a CRF, they can actually range from negative infinity up to the maximum value of 1. And that's for the crash reduction factor. Crash modification factor can range from 0 up to a maximum of infinity. Crash modification factor can go all the way up to infinity, theoretically at least. And so, again, it's important to understand the difference because, the numbers mean different things. For instance, if you have no change in crashes, if your crash experience after the countermeasure is the same as before the countermeasure, then your crash reduction factor is 0. You have reduced 0 crashes. You've made no change. Your crash modification factor, if you had no change, is 1.0. It's the same. It's a multiplicative factor, the crash modification factor. And so, the 1.0, you multiply something by 1, you get the same number. Whatever you have, multiply it by 1, you're always going to get the same number. And so, no change in your crash rate, crash modification factor equals 1. Now, let's say you're extremely successful. What you do eliminates all of the crashes. The crash reduction factor related to that is 1.0. You've eliminated 100% of the crashes. And so you've reduced 100% of the crashes. Crash reduction factor is 1. If you eliminate all the crashes, your crash modification factor, the multiplicative factor, is 0 because you've now taken it down to 0 crashes. And so crash modification factor is 0 if you eliminate all the crashes. And then now it gets a little interesting. When you double the number of crashes, so you had, let's say, 12 crashes one year, the next year you experience 24, your crash reduction factor is -1. That sounds kind of bizarre, but you've reduced 100% crashes, or you've reduced negative 100% crashes because you've increased 100% of the crashes. And so when you double the number of crashes, your crash reduction factor is -1.0. If you have double the number of crashes, crash modification factor is 2.0 because you've doubled the number of crashes. So we've had 12 one year, 24 the next. It's real simple. 2.0 is the crash modification factor. Likewise, half the number of crashes. This is when you have half the number of crashes, this is where they do line up and they're equal. You have a 50% crash reduction factor and your crash modification factor, because again it's multiplicative, is 0.5 as well. And so you can see for the others, 0.15 for the crash reduction factor shows you have 15% less crashes. That equates to a crash modification factor of 0.85. And likewise, if you have 15% more crashes, it's a -0.15, and crash modification factor of 1.15. So basically, one of the things you can identify, if you have an increase in crashes, the crash reduction factor is always going to be negative. If you have an increase in crashes, your crash modification factor is going to be greater than 1. And so just some important things to remember there as you're using crash modification factors or crash reduction factors. The relationship between crash reduction factors and crash modification factors, mathematical relationship, is on the bottom of the screen there. CRF equals 1 minus the CMF. Or if you want to do the algebra, you can move those around. And the CMF is also equal to 1 minus the CRF. And so that's the relationship between the crash modification factors and crash reduction factors. But it's important you understand, again, what the different numbers mean and, just the scope of how they're used and, what a negative crash reduction factor means, which is an increase in crashes and so forth. All right, so where do I find crash reduction factors, crash modification factors? Where do I find these factors to use for different countermeasures that I might want to implement? Well, Florida DOT has a list of crash reduction factors based on studies in Florida, and that's some really good data. That's one really good source. Crash reduction factors, or actually crash modification factors, are found in the Highway Safety Manual. You can find CMFs in the Highway Safety Manual. And if you don't have this website, it's something you probably want to make note of, the CMF Clearinghouse, and it's cmfclearinghouse.org. And this is a Federal Highway Administration website that keeps a database of all the known crash modification factors and what they're applicable to. And we'll spend some time looking at that as we go through the slides. But that's a really good resource there, the CMF Clearinghouse. All of the CMFs that are in the Highway Safety Manual are in the CMF Clearinghouse. So you can find all the stuff that's in the Highway Safety Manual in that online website, plus a lot more recent stuff is in the Clearinghouse. So, but those are three good sources for CRFs and CMFs. The DOT, Florida specific ones, the Highway Safety Manual, and the CMF Clearinghouse online. The Florida DOT CRFs, again, it studies in Florida, so it's much more localized stuff much more related to, Florida's roadways and how we do things here. So there's some really good information there. It was produced by the Lehman Center at Florida International University, and based on a program that they developed, the Crash Reduction Analysis System Hub, and the crash system just keeps a database of all the different projects, different countermeasures, and what the crash modification experience based on the countermeasures that were implemented. It just has a database of all that kind of stuff. And again, it's studies done in Florida, and it's an attempt to have a centralized database for that kind of information. It was updated, I believe, last in 2005 in terms of the printed report, but they do keep this stuff current online, and working with either the DOT central office or your district safety office, or if you call up the folks at FIU, you can see if they have even later greater stuff than what they printed in 2005. They should. And actually, for all the folks there at District 7, this is an update to Peter's graduate school work when he was a graduate student at University of Florida. Peter really was one of the pioneers in Florida-specific crash reduction factors, and so it really is an update and a continuation of Peter's graduate school work when he was a grad student at University of Florida. Highway Safety Manual is one of the other sources I mentioned. The tables in the Highway Safety Manual contain crash modification factors. It is one of the things, like I said, there's some confusion, crash reduction factor, crash modification factors. For many years, many people like me have been saying, we need to just pick one and use one, and because it's confusing having two different types of numbers that mean different things and that kind of stuff. And they did try to standardize on crash modification factors, and so the Highway Safety Manual really lists just CMFs. And if you want CRFs, you have to do the conversion, so you have to do the 1- to convert it. This is an important thing. If you have the Highway Safety Manual, it's a 3-volume edition. There are separate crash modification factors for the predictive models that are in Volume 2 versus the project-specific stuff in Volume 3. And so you really must be aware of the fact there's different CMFs for the predictive models versus project analysis, or when you're implementing different countermeasures in the field. And what the Highway Safety Manual says is typically the CMS for the predictive models should not be used for other purposes, and the other CMS from Volume 3 should not be used with the predictive models. They don't cross over. They haven't been calibrated to cross over. So if you're going to be using the predictive models out of the safety manual, use the CMFs that are appropriate for that and not the ones out of even the online CMF resource. I mean, just use the ones that are in the Highway Safety Manual if you're using the predictive models in the Highway Safety Manual. CMF Clearinghouse, again, the website is cmfclearinghouse.org, and this is just a screenshot of what comes up when you type in cmfclearinghouse.org. And again, it's an online database where you can find different crash modification factors. You can type in terms to search for, and it can come up with different countermeasures for you there. But here is where I show my age a little bit. That's the robot from Lost in Space, and he would always flail his arms around and say, "Warning, danger, Will Robinson, danger, Will Robinson, warning." And you must always use some caution when looking up or applying CMFs or CRFs. I mean, the title of this webinar is Use or Misuse, and there's a lot of misuse of them, and it's because people really just don't pay attention to all the text that's there. You really need to understand what's in the tables when you're pulling a crash modification factor or a crash reduction factor out. And so you want to make sure you're paying attention to all the information that's displayed there so you choose the right CMF. I mentioned the Highway Safety Manual predictive models. This is a list of the ones up until the very recent update. They added now freeways and interchanges, but up until that update, everywhere you see a check, there is a predictive model. For rural 2 lanes, there's undivided roadway, the segment model, and then there's for intersections either 3-leg, 4-leg stop control, or a 4-leg signalized. There is a HSM predictive model, and so for each of the models, there are crash modification factors that are associated with that model. And I'll just talk about these briefly. Just again, you must understand those CMFs that are applicable for the model shouldn't be used for your project analysis, or if you're looking at installing a certain countermeasure, don't use the ones for the predictive models. Use the ones that are more applicable to that particular countermeasure. So anyhow, these are the different facility types with safety performance functions in the Highway Safety Manual. And looking at the predictive models, the safety performance function is based on the facility type, and there's crash modification factors, or crash modification functions in some case, that go along with each of those safety performance functions. And then we also need to apply a calibration factor to calibrate it from the fairly generic Highway Safety Manual perspective to a more localized, Florida perspective. If you have good crash data, good reliable crash data, you can also apply the empirical Bayes adjustment that combines the predictive method with your real-world experience. And I mean, that's a very good thing to do, very robust thing to do. We did a separate webinar on the empirical Bayes analysis, and if you have some interest in that, I'd recommend you go back and you can pull up the audio of that, or pull up the video and watch that particular webinar, because we talked there about the empirical Bayes adjustment and when to use it and how to use it and that kind of stuff. But this is for the Highway Safety Manual predictive models, and again, there's crash modification factors associated with the predictive models, but the ones that are associated with the predictive models really belong being associated only with the predictive models. So what are the safety performance functions? Safety performance function is a mathematical regression model for either segments or intersections that are developed from data from a number of similar sites, and they're developed for the specific site types, what type of roadway you have, and is it a four-legged intersection or three-legged intersection that is stop controlled or signal controlled or whatever. So it's developed for certain site types and roadway site types and the base conditions. And I'll talk some more about what base conditions mean in a little bit. The function of the predictive models is to try to give you an estimate of the expected crash experience based on typically a very few number of variables, typically AADT. You put in your average annual daily traffic, and you crank through the model, and you come up with a predicted number of crashes per year that you can expect. And they use to calculate, like I said, the expected crash frequency, the crashes per year for the base geometric and traffic control conditions at that location. The crash modification factors are used with the safety performance functions to convert from the base conditions to what your real, actual, or proposed conditions are. And it really accounts for the difference between the base conditions and your site-specific conditions. Here's the predictive model for a rural two-lane roadway segment, and you can see the NSPF-RS is the number of crashes you would expect based on the AADT, the length of the segment, and the rest of the stuff over there is a constant. And so you plug in your AADT, plug in the length of your rural two-lane roadway segment here, and you can come out with your predicted number of crashes per year on that segment. Now the base conditions for that rural two-lane roadway segment are that your lanes are 12 foot wide, your shoulders are 6 foot wide, you have paved shoulders. This thing, the roadside hazard rating, is an interesting thing. It's a kind of qualitative estimate of what the roadside is like. If you have a whole lot of driveways or if you have a whole lot of trees close to the road, your hazard rating will indicate that there's a lot of hazards in the road. If if you've got really good flat clear zones and all that kind of stuff, then it'll be a more safe roadside hazard rating. The roadside hazard rating of 3 is the default, and that's kind of in the middle kind of thing, that you've got some trees, some driveways, but a lot of places where it's pretty good. And so that's what the roadside hazard rating is all about. If you have more interest in that, again, read the Highway Safety Manual. It has a good discussion and some guidance on how to pick the number for that. Driveway density is, again, one of the base condition things here. The grades, is there horizontal curves, vertical curves, rumble strips? Is there a two-way left turn lane? Are there climbing or passing lanes on this rural two-lane roadway? Is there lighting? Is there automated speed enforcement? And so for these, for all of the elements that you see on the screen here, these are the listed base conditions, and there is a separate crash modification factor for each of these things for that rural two-lane roadway segment model. And so if you have something less than 12-foot lane width, for instance, and so your lane width is different than 12, there's a crash modification factor that you would apply that would either raise or lower the expected number of crashes based on the lane widths. And then a separate thing for the shoulder width, shoulder type, and so forth. So crash modification factors would be available for each of these identified things here, each of the elements here that describe the base conditions for a rural two-lane roadway segments. And likewise, for other roadway types, intersection types, or whatever, there's a certain number of things that specify the base conditions, and each of those things have a crash modification factor associated with that. So we then, whatever we come up with is the number for the base conditions is multiplied by all those crash modification factors. And so the crash modification for lane width, for shoulder width, for all those other things that we just listed on that previous page would be multiplied by the predicted number from the equation, or from the safety performance function, to come up with our predicted number. The calibration factor at the end here is a local calibration factor, like I mentioned, and Florida, through the central office DOT, has come up with some calibration factors to be used in Florida with this predictive analysis. But again, the real point of this, we're talking about the crash modification factors. And so all the different crash modification factors for the individual design elements, are multiplied if you have things that are different than those base or ideal conditions. Here's just an example. Again, this is for the lane width thing. And so the lane width, this is the table where you would pull up the crash modification factor for lane width using that two-lane rural roadway predictive model. And actually, this is not really a crash modification factor. As we see here, it's a crash modification function, and a lot more of the development of the Highway Safety Manual in the future will probably have more crash modification functions. That the factor that you come up with is really a function of some other variable, in this case AADT. You go in with your AADT and what your lane width is on the left side of the chart, plug in your AADT, and you come up with a crash modification number, crash modification factor based on this crash modification function of lane width. And so there's, again, it sounds real complicated. You just have to pay attention to the details. The details tell you, that the information you get here, the collision types related to the lane width to which this crash modification factor applies, includes single vehicle run off the road, multiple vehicle head-on, opposite direction side swipe, and same direction side swipe. Other crash types may not be addressed, by the lane width crash modification factor. And so you then have to apply the equation you see at the bottom underneath the table to get the appropriateness of this crash modification factor number based on the proportion of the crashes that are related. And again, this stuff's covered in the Highway Safety Manual, but you got to dig through the details if you're really going to use the predictive models. District 7 has some really good data in the crash data management system. We can get some of these factors out of the crash data management system for many of the things that we're trying to do. So try to use District 7's good data if you can get it. But again, my warning, and you'll see this a lot, use caution when looking up or applying the crash modification factors or CRFs. All the stuff I just showed you on that previous slide is only applicable for the predictive model for rural two-lane roadway segments. So, for urban and suburban arterials or some other type of roadway, that stuff you just saw is not applicable, and so you have to have, you have to find the right table to get the right value, and so you want to make sure you are using the right table and getting the right value. Now this, a lot of information on the screen here, but this is a quote straight from the Highway Safety Manual when you're using crash modification factors. The predictive method, the safety performance function estimate is multiplied by a series of crash modification factors to adjust the estimate of the crash frequency from the base condition to the specific conditions present at your site. And the assumption is that the CMFs are multiplicative because it's presumed that the features are independent, that the lane width is independent of the shoulder width. But like it goes on to say here, little research exists regarding the independence of these effects, but based on the current knowledge, they consider it a reasonable assumption. But you want to be somewhat cautious in using them, because when you start multiplying all these different crash modification factors together, the presumption is that all these little things are independent of one another, and that may or may not be the case. And so again, it's just have to be really careful and cautious when you're pulling several crash modification factors. So are they really independent? This is another quote straight out of the Highway Safety Manual. Crash modification factor is also used in estimating anticipated effects of proposed future treatments. And the limited understanding of the interrelationships between the treatments presented in Part D requires consideration, especially when more than 3 CMFs are proposed. And again, if you're multiplying crash modification factors together, you're presuming that the effects are independent. And so the implementation, like it says here, implementation of wider lanes and wider shoulders along a corridor is an example of a combined treatment where the independence of the individual treatments is unclear because they both should be expected to reduce the same crash types. And so, again, the real caution here, the real point behind all this is really you have to be careful when applying crash modification factors, and especially if you're going to be trying to apply multiple crash modification factors, it is essential you really think about, are they really independent, or are they somewhat related, and should I just choose one of them? And so again, just use a lot of engineering judgment and caution when you're trying to combine crash modification factors, because again, when you're multiplying them together, when you're using more than one crash modification factor, the assumption is that the things are independent. And if they're not independent, again, you really shouldn't be using more than one crash modification factor. And so this talks about installing a roundabout at an urban two-way stop controlled or signalized intersection. There isn't a SPF for a roundabout presently, but you can apply a crash modification factor for converting a conventional intersection to a roundabout. But installing the roundabout changes the nature of the site so that many other CMFs that might have been applicable to that other thing are no longer applicable. And so again, it's just warning after warning. And again, these come straight out of the Highway Safety Manual that if you're using crash modification factors, you really need to think about, is it applicable, and especially if you're looking at 1 or 2 or 3 or more crash modification factors, are they independent? And if not, then you may not want to use all of them. So again, warning, warning, always use caution when you're looking up or applying crash modification factors, and especially combining them. You can combine crash modification factors, but don't try to combine crash reduction factors, convert them into crash modification factors. Don't combine crash reduction factor. Just don't do it. That's the opposite of Nike's ad. But don't do it. So when it comes to combining crash reduction factors, just don't do it, because they're certainly not additive. If you have one thing you think is going to give you a 25% reduction, and you do some other thing that's going to give you a 35% reduction, you really can't add those together and say, I'm going to get a 60% crash reduction. So you don't add crash reduction factors. The thing to do is convert them to crash modification factors, and then if they are independent, you can multiply them. So if they are applicable, then after you've converted to crash modification factors, you can multiply them. So like I said, multiply if they're applicable. Really think about, are the things independent? Is putting up a sign or putting up a few warning signs independent in terms of the crash reduction to painting a crosswalk, or putting in a hawk, hybrid pedestrian beacon. So are those things independent? And if they are independent, then they can be multiplied. The Highway Safety Manual really cautions you to use a maximum of 3, and for most of the stuff that you'd be submitting to District 7 for consideration, we really prefer you stick with 1. I mean, find the one that is most applicable and stick with 1. If there really are, you're doing a couple different treatments that really are defensively independent, certainly, then we could consider 2. But certainly when you start getting into 2, 3, or 4 crash modification factors, they're most likely they're not as independent as they probably should be. So again, one of the great sources for crash modification factor is the CMF Clearinghouse. And so again, cmfclearinghouse.org. And if you go there, they often you'll see listed right on the front screen, some recently added crash modification factors. Scroll down a little bit here, and you can one of the ones we'll look at real quick: installation of the high intensity activated crosswalk, the Hawk pedestrian beacon at an intersection. And so you can see it lists crash modification factor 0.309, which is a resulting crash reduction factor, 1 minus that of 69. And so it shows a 69% crash reduction factor. That sounds really, really good. But again, you really need to pay attention to the details when you're looking at that kind of thing. When you click into that in the clearinghouse, it takes you to a page that describes that particular study and this safety effectiveness of the Hawk pedestrian crossing treatment. Oops, let me back up there. One of the things to mention is right at the top, the star quality rating. This has 3 stars, and the 3 stars is really indicative of how reliable or how good we believe the crash modification factor from this study is. And the way they come up with the star quality ratings, when a study is submitted, the study is reviewed and it's ranked based on the things you see here: the study design, the sample size, standard error, potential for bias, and the data source. And for those different criteria, it's ranked either excellent, fair, or poor based on the information you see on the screen. And so if it's ranked excellent in a particular thing, it gets 2 points. If it's fair, it gets 1 point. If it's poor in a particular area, it gets 0 points in that area. And so all the studies of different implementations of different devices are reviewed and ranked in this process. And then it goes through the final quality rating is based on a score that's twice the study design score, twice the sample size score, plus the standard error, plus the bias, plus the data source scores from what we just looked at. And so the star rating is assigned based on the adjusted or weighted score there. And so if it gets the maximum possible of 14 points, it's a 5-star. And you can see the rest of the table there. So if this particular one for the Hawk, we had 3 stars, so it had a score somewhere between 7 and 10. So again, back to our sheet here. From the web page, from the clearinghouse, it's detailing this particular crash modification factor. Again, crash modification factor 0.309. Sounds really good. 69% crash reduction factor. Sounds really good, but again, you got to dig into the details. Dig further into the details, and you see, yes, it's 69% crash reduction factor. It's a decrease in crashes, but it's really applicable only to vehicle versus pedestrian crashes for all crash severities. But the studies were done on 4 to 6 lane roadways, 30 to 40 mile/hour speed limit, urban and suburban area types, and so this is giving you some criteria for where this particular value or these this particular crash modification factor might be applicable. And so again, just digging into the details of those studies. Now, if you go back to crash modification factor homepage, the front page of it, if you type in Hawk and search for Hawk, so you just put in the search terms you want there, and it brings up 3 different studies. There's 3 different crash modifications returned for just the search of the word Hawk. So in addition to that one that was highlighted on the front page that we looked at real quick there, if you go back and search for Hawk, there's a couple of other crash modification factors listed in the clearinghouse. And actually, it turns out that all 3 of these different crash modification factors actually came out of that same study. And so it's important you understand, again, the devil is in the details. You have to pay attention to the details here when you're looking up crash modification factors in the clearinghouse. And so you can see 3 different values for crash modification factor for the installation of a Hawk beacon at an intersection. but there's, like I said, 3 different factors, and there's 3 different things to the factors. The first one here, it's for all crash types, for all crash severities, and urban and suburban areas. The next one is all crash types, but it's only talking about fatal and serious injury crashes. So the crash modification factor is 0.849, 15% crash reduction factor of fatal and serious injury crashes. Whereas we see the one up above, where it was all crash types and all severities, the crash reduction factor is 29%. And then the one that we looked at before, the 0.309 crash modification factor, again, is really applicable only to vehicle versus pedestrian crashes. And so you can get a 69% reduction, not of all crashes, but a 69% crash reduction of vehicle versus ped crashes. And so, again, it's important you grab the right factor and you apply it the right way and you understand the details of what you're grabbing when you grab that number. So, at first blush, when you looked at the, that 0.309, that sounds like a great crash modification factor. But then you dig further into it, and that's only applicable to vehicle versus pedestrian crashes, not all crashes. And so it can only reduce whatever your number of vehicle versus pedestrian crashes are. The interesting button at the top of the things, when you do a search up there, if you see the red arrow, it says check out our FAQs, and that's a really good thing to do when you're trying to choose, gosh, there's 3 or 4 or sometimes 10 different CMFs here. Which one do I want? Click the button up there, check out the FAQs. The frequently asked questions walks you through the answers to which ones you should choose. So, it says, as you see here, it's true 2 or more CMS, they have the same star rating but different CMF values. And so you have to look at, what are they applicable to? How are they different? And so just like the example we looked at for the Hawk, the one shown here in the FAQ is the installation of a left turn lane on a single major road approach. And you can see there's different CMFs and different criteria for when you choose which ones.
Larry, there's a question in the chat asking for clarification on the HSM. You mentioned that if you're using the predictive model, you should use the CMFs from Part C of the HSM. Mm-hmm. When do you use the CMFs from the clearinghouse?
The CMFs for the clearinghouse really are not for the predictive model unless it mentions that it's for the predictive model. It'll say that it's for the predictive model. These from the clearinghouse are more for projects or for the type of work where you're looking at specific countermeasures you're going to implement. So this, typically the stuff in the clearinghouse is not for the predictive models. That's a great question. I hope I answered it adequately too. That, I mean, what you get out of the clearinghouse really is not applicable to the predictive models. I mean, unless it does say so, unless it talks about it's directly applicable to the safety performance function. Excellent question. That's good. And again, that's part of the confusion and how people misapply them is they grab hold of the wrong CMF and used it in the wrong place. And so, again, the stuff that's for the predictive models, pull out of the book, and the stuff in the CMF clearinghouse, unless it says it's for the predictive model, it's for the Part D stuff, if you will, the Volume 3, the project-specific stuff. But excellent question. All right, and so like I was mentioning, for the initial review or initial view of the search results, you can see it's relatively easy to tell the difference between the first CMF and the other two. One is rural, the other two are urban. And so the crash modification factors, are vastly different. But again, the one in the top listed here, the 0.65, is for rural areas, where the other two are urban. And then you have to decide which one do I use, for the urban area. They all come from the same study. It looks like they're all the same. So you have to dig deeper into the study, dig deeper into the details. And as it says here underneath, digging deeper into the study, you see that the 0.71 is for stop-controlled intersections, 0.91 is for signalized intersections. So again, you don't just grab the best-looking one and go with it. You need to dig into the details and find out which one is appropriate and which one is not. And so, again, the FAQ page is there in the clearinghouse to help drive you to the right, to drive you to choose the right answer. So, and there's other FAQs there on that page, and I just want to again highlight it because there's good information there that explains what the star quality means. How do you submit your own crash modification factors for including in the clearinghouse? Lots of information here on how the CMF clearinghouse should be used and how to get the right one. Make sure you use the help here in the FAQs because it can help you find the right factor. Very important that you dig through the details to find the right one. Now here I did another search, and I searched for protected left turn. And there's 67 crash modification factors returned for protected left turn. And so again, it's got the buttons here to check out the FAQs, or to refine your search with search tips to reduce it down from 67 if you want. But as I started looking at the 64 related to intersection traffic control, you can start to narrow down, and you just click on these. Am I changing from permitted or permitted protected to protected? Am I changing from a permitted left turn to protected left turns on the minor approach? And so whatever you're doing in terms of going from permitted protection to protected only left turns, you can find one of the countermeasures that hopefully is more applicable to whatever it is you're trying to do. And so you can expand those things. You click on them and expand them, and you can see, for changing from permitted to protected on the minor approach, a couple different studies. And one of them, CMF 0.01, that means 99% crash reduction factor. Wow, that sounds really good. But it's only applicable to what it calls angle crashes. And this is something where people that are really into crash data like Anthony will say, wait a minute, those aren't angle crashes, those are left turn crashes. And Anthony is really correct, but for the highway safety manual and the highway the CMF clearinghouse perspective, that left turn crash is considered an angle crash because the left turn is getting hit by a through vehicle typically. So it is another one of the things you have to be cognizant of, the terminology that the highway safety manual is using here. And so what it's saying, if you go from a permitted left turn, where all you see is a circular green and you're yielding to oncoming traffic, to a protected left turn, protected only, where you can only go on the green arrow, it's going to eliminate 99% of your left turn crashes, really. Again, they call them angle crashes, but left turn crashes. And that should be expected. But in terms of all crashes, that same study showed it was a 18% crash reduction factor. It's getting, almost all of the left turn crashes have gone away because it's now a protected only movement. But, that makes up a component of all your crashes on the intersection, but you've got other crash types that you would be experiencing there. So anyhow, this is how you use the information from the clearinghouse. And again, the real point I'm trying to make is you got to really dig into the details. Don't just grab the first thing that pops up and the first thing that sounds real good, because most likely you will be misapplying the CMFs if you just grab the first thing that sounds real good. I mean, this, a 0.01 CMF sounds real good, but again, it's only applicable to your angle crashes. And so, again, it's just, the point is, make sure you dig into the details, get the right factor, and just take time going through the details, reading the details of the study, and make sure you're getting the one that's applicable to what it is that you're trying to do at your particular intersection. One of the things also talked about some in the Highway Safety Manual is precision versus accuracy. And so, there's a compilation of studies done, and you compile all these studies and average it. It can be precise but not accurate, where they're all off-center, but they're grouped pretty tight, and that's precise but not very accurate. Or they can be spread all over the target, and again, when you average all those together, you get something maybe closer to the target, but there's a lot of variability. And so, same with all these studies that combine to create crash modification factors. Some of them are extremely precise, but may not be accurate. Some are neither precise nor accurate. What you hope you're getting is something that's fairly precise and also accurate. And so, again, it's just important to understand the difference between precision and accuracy there. Again, another search in the CMF Clearinghouse for roundabout. And again, just type in the word roundabout to the search, and here it popped up. We have 134 crash modification factors related to roundabout. And so then you can just start clicking on these things and expanding it. And under intersection geometry, there's 113 related to just intersection geometry. And you can see for each of the different countermeasures listed there, again, you can click on those, and it expands it and tells you the studies related to each of those things. So, for instance, converting a no control or yield intersection into a single or multi-lane roundabout, it's interesting. Look at the crash modification factor, 1.24. That means you get a 24% increase in crashes converting a yield controlled intersection into a single or multi-lane roundabout. But if you look at your crash modification factor for your fatal, serious, or minor injury crashes, it shows 0. So you're increasing your total number of crashes, but you're decreasing or eliminating all your fatal, serious injury crashes by doing this conversion to a roundabout. And so, that's a fairly substantial thing to accomplish there, eliminating all of your fatal injury crashes, especially have a lot of them. That might lead you to consider a roundabout for sure. Oops, let me back up again. Yeah, conversion of a signalized intersection to a single or multi-lane roundabout. You can see the crash modification factors, and again, you have to dig into the details. Where it's applicable is, you can see a great crash modification factor, 0.29, again for serious injury and minor injury crashes. So, it shows that roundabouts do tend to really reduce severity of crashes, and in many cases, can reduce the number of crashes. But in the case we saw up at the top, actually 24% increase in the number of crashes, but it eliminated all the fatal and serious crashes. And again, same kind of thing, conversion of stop-controlled intersection into single-lane roundabout. You can see very significant crash modification factors, reducing the number of crashes and reducing, in particular, serious injury and minor injury crashes. But again, when you look at converting an all-way stop-controlled intersection to a roundabout, again, it's an increase in crashes, but typically you've greatly reduced the injury crashes, but your other type crashes, rear-end collisions or side swipes or those kind of things may go up, but they tend to be minor and less severe. All right, another just point, accuracy versus precision. This figure comes straight out of the Highway Safety Manual, and the spread of the points here, the data, is all over the place. They did a bunch of studies of two-lane rural roads, basically the AADT versus the crashes per mile per year. The red line is the formula, that safety performance function that comes out of the Highway Safety Manual for two-lane rural roads. And you can see that there's a lot of spread there based on the studies in Colorado. And so, there's some accuracy and precision questions there, isn't there? I mean, you can see how the data is spread all over the place. But the line is what you get out of the equation. It gives you a specific number when you put in a specific ADT, you'll get a, you'll crank a number out of it. But all of the points have been averaged into that regression line that, is the safety performance function. All right, let's look at one quick example here. You've got a 2-lane rural roadway, and your AADT, your average annual daily traffic, is 16,000. You've got some nighttime and wet weather crashes. It's a county-maintained roadway, and right now there's currently no RPMs on it. And so, well, hey, why don't we enhance the delineation? Maybe let's put some RPMs on it. Okay, so let's think about it. Let's add RPMs on this road. And if we go to Part D of the Highway Safety Manual, this table is straight out of Part D. And there's a crash modification factor for installing snowplowable permanent RPMs. You say, wow, snowplowable permanent RPMs? Again, I issue my warning, always use caution when looking up or applying the crash modification factors. Is this one applicable? The text says it's, excuse me, the installation of snowplowable RPMs. And this is a snowplowable permanent RPM. They're a lot more expensive than what we typically use in Florida because they're embedded deeper in the pavement so that when the snowplow runs over them, they hopefully won't be popped up. But I would ask the question, isn't every single RPM installed in Florida resistant to every single snowplow typically used in Florida? I mean, we're not using any snowplows in Florida, so the RPMs we put out there are certainly, snowplowable or resistant to the snowplows since we don't have any. So you could make a case for, well, maybe this is applicable. But again, you want to proceed with caution. You could say, well, maybe it's applicable because all the ones we put in are completely resistant to all the snowplows we use, which is 0. So maybe we can use this. But again, check the notes. The note under the table says, the bold text is used for most reliable CMFs. All the ones in our table are bold. And so these CMFs have a standard error of 0.1 or less. And so, it goes on to tell you the variability suggests could result in increase, decrease, or no change. So again, here's our table, and again, all the CMFs are in bold, so it says they're really pretty good. They feel they're pretty reliable. But it's interesting as you look at these numbers. I mean, look at the numbers I've circled here. Does this make sense to you? When I first looked at this, I'm like, wow, you're getting 16% increase in crashes, or 43% increase in crashes, 26% increase in crashes by putting in RPMs. And so again, you dig into the details. You got to look through the details and understand what's going on there. What are they saying? And the text says that basically what they found is by putting in the RPMs on these roads, people tend to drive faster because they have better delineation. They tend to drive faster, but the roads may be icy or slick or whatever, and then they slide off the road and get into a crash. And so by increasing the delineation in the places where they did these studies, it actually increased the crashes because people were driving faster because they could see better because they had better delineation. So again, the devil's in the details. You got to check the details. So, but in the example that I spelled out here, we're looking at nighttime crashes, and so this crash modification factor is only applicable to nighttime crashes. And what I gave you was a 2-lane rural roadway, 16,000 is the AADT. You got nighttime and wet weather crashes, and no RPMs. So 16,000 was our AADT. We would go in here, 16,000 nighttime crashes, and we could apply a crash modification factor of 0.76 to our nighttime crashes if we believe that this is applicable crash modification factor to use. So the big question, what do we do? And so, what would Larry do? So crash modification factor 0.76, is a crash reduction factor of 24%. What do you do? Well, again, it only is applicable to the nighttime crashes, not the wet weather crashes, but nighttime crashes. Maybe you say, well, I'll use 80%. I'll be a little conservative, as my crash modification factor. So I'll presume a crash reduction of 20%. Be a little conservative. And then really the best thing to do is try it. See if it works. perform good before and after studies and submit your results to the clearinghouse. Submit a study to the clearinghouse so we have better data, so we have more data, because really the clearinghouse is looking for more data. We need better data. We don't have really good data in there in a lot of cases, and we need better crash modification factors in more categories. So that's what Larry should do. If you really want more information on applying or misapplying CMFs, I want to highlight Federal Highways actually did a webinar on applying or misapplying CMFs and the ins and outs of estimating crash reductions. They did it just back in December, not that long ago. If you go to the CMF clearinghouse, you can access the webinars there, and you can watch that webinar that Federal Highway did, again, just back in December. And so there's some good information in that webinar. I cannot offer you a PDH for attending that webinar, but you can get one for this webinar. But I do also want to issue the warning again, because there's some information in that webinar. I was on that webinar, listening to that webinar when they were doing it, and some of the stuff I kind of disagree with. They were, I think, misapplying some of the crash modification factors, because, again, if you see one crash modification factor that's really good, that applies very good crash modification factor to your left turn crashes, you can't really go and get another crash modification factor that applies to all crashes and use that in concert with that. And they were kind of hinting that you could, and you really shouldn't be doing it that way unless you really separate out all your left turn crashes. And I don't know, I think you're really double counting the benefit when you try to use the one that's for left turns and then also use the one for all crashes. So I really would caution against doing that. And I think I've reached about the end of my time here, so I'm going to say that's all. But before I close, I do want to just remind you, if you are an engineer and want your PDHs, submit your PDH form to me. You can either email it to me or fax it to me. I'm sorry that I had forgot to post the 2015 form before the last webinar series, so if you were on the last webinar and didn't find the form is now out there, and so you can fill out the form. The first blank is just it's a list. You just pull down the list, select the form, put in your PE number, your name, and your email address, and send it off to me, and we can get your PDHs issued. Well, like I said, it's fun, fun, fun till your daddy takes the T-bird away. Well, there goes the T-bird. And so with that, I'll take any questions. So, Anthony, any questions in the chat box?
The only question in the chat was already answered. It was about the crash modification factors using the HSM, which you discussed earlier. We'll give folks a few minutes to see if anything else gets typed into the chats. Yeah, this whole webinar is a very good topic because right now it's open season for the local agencies in District 7 for the Highway Safety Improvement Program application. And this is critical, having the crash modification factors done right. It's very easy to, there's a lot of numbers and a lot of steps, and it's very easy to pull the wrong number and then the whole thing is off. So it's, again, use caution, use common sense, and get the numbers.
Yeah, absolutely. I mean, it is critical that you really read through the notes when you're grabbing one of the crash modification factors. And so make sure it really is applicable, because, I mean, even if it has a great value, don't just grab the one that has a great value. You really want to make sure it is applicable to what you're trying to do. And again, I want to highlight the fact that that it's really good if you do good before and after studies to back up the projects that you're doing, because the CMF clearinghouse really needs more data, good data that can help other agencies further down the road, help you further down the road. And so if you can contribute to the knowledge base, contribute to the information that's out there that'll help other agencies that are, trying to do the same kind of stuff.
In your slide for the PDH form, did you have the web address on there, or should I bring it up on my end? There was someone had that address.
I did not. Yeah, I did not have it on there. So if you want to bring up that web address, yeah, that'd be a good idea.
I'll change myself to the presenter again here for a moment.
Mm-hmm.
It is up for the Tampa Bay Traffic Safety.com webpage. If you Google that, it'll come up, and it should. Am I the presenter now?
Are you?
I believe so. No, change presenter to me. Oh.
Do I need to change you?
No, I got it. I have a screen letting me know
Okay.
if I was ready to show my screen.
Yep.
So it is, if you Google just TampaBayTrafficSafety.com, you'll end up here. And under the education component.
Are you showing your screen? I don't see your screen.
Oh, I'm sorry. Screen number 2. There we go. Yep. Can you see my screen now?
Yep, got it now.
Okay, perfect. So when you go to TampaBayTrafficSafety.com, it takes you to this location. Under the Education tab, we have the Local Agency Traffic Safety Academy, LATSA, which is what we're doing now, and this is the home page. This web page, I believe, is also part of the text in your invitation that you received from GoToMeeting. So this hyperlink is on there as well, and all the way at the bottom of this page, there is a document library with resources, and your PDH request form is right here.
Yeah, so I used the 2015 form for today's webinar, and if you were in attendance at the last one and you couldn't find the form, I need a separate form for each webinar, but go ahead and submit them as soon as you can, and especially renewals are due at the end of the month. If you haven't got your renewal done, you need to get it done soon. So, yeah, by all means.
You can see what the form looks like, and you click download. You download a local copy of it, and then this is actually a drop-down that allows you to select the name of the webinar that we just saw. Type your name, type your license and your email address, and send that over to Mr. Hagan here, Larry. Not Curly or Mo. Got to send it to Larry.
Yeah, don't send it to Curly or Mo. Send it to Larry. And yeah, the best thing is to download it to your PC, and once you fill in all the other information, your PE number, your name, and your email, save it to your local PC, and then next time all you have to do is pull down the item, change it, and you're ready to send it. And so it makes it real easy and simple to fire off the form at each webinar. All right, did anything else come in the question box here?
Please provide Larry's email. Larry's email is right on the form, larry@larryhagenconsultingservices.com.
Okay. She says she doesn't have the original email. If you can put the...
Yeah, how about
go back to the... Because if you don't have that original email, you need to type in that address, and it is case sensitive. TampaBayTrafficSafety.com. Everything after the .com is case sensitive, so LATSA all has to be uppercase. Site pages has to have capital S, capital P, and home has to have capital H and that kind of stuff. So if you're typing it in from scratch, it's got to be exactly what you see on the screen.
This is Dennis Falloon. I just want to remind everybody that's still online, the attendees, that if you have any questions after you get off today, please direct them toward Larry Hagan or to Anthony or myself. And if we can't answer it, we will get you an answer. So I'm pretty sure we'll be able to answer things for you. But just want to make sure you understand that. Well, Larry, I appreciate it. If there's no more questions, great job.
Oh, well, thank you. Well, I hope everybody got something useful from this.
Anthony, you have anything else? Or Larry?
No, I do not. Just look for the look for the webinar video, this recording, and the PowerPoint of the recording to be added to this 2015 Local Area Traffic Safety Academy document library set. This is where we're going to be posting the 2015 ones. And we'll see everybody in about a month. There's when is the next one?
March 18th.
March 18th. FDOT Strategic Statewide Bicycle and Pedestrian Policy Update is the next webinar that is on March 18th. So you should be getting your notices via GoToMeeting like you have been. I believe it's set to 3 weeks prior, the week of, and a day prior. So we'll see everybody next week. I'm going to go ahead and end the recording now. Thanks everyone for attending. We'll stay on the line for a few minutes if anything else comes up.